My name is Pablo, and I'm going to make a quick summary of the updates that have happened in the Netfilter landscape since the last Netdev conference. It's been already 1 year since that. So I'm going to make a brief summary on upstream updates on iptables, ipset, conntrack, IPVS, the new flowtable infrastructure, nftables, and nftlb, and just add one single slide to discuss a few more items that are pending. So what's new on the iptables and ipset landscape? So not much actually. In iptables, there just one single target extension that came new. It's basically this idle timer version 1. This is a new revision. So this idle timer target was already available, but there is a new alarm mode, and it's quite specific. It has a very specific use case, basically just to continue to run even when the CPU is suspended state. So it's a very small incremental update on existing idle timer target. And what we have in user space was 3 releases from 1.83 to 1.85. So mostly user space updates, and those updates has been covering basically improving the integration with the new nftables backend. So just to allow users to run iptables command seamlessly using the nftables backend infrastructure. So most of those changes went into these iptables to nftables backend support. So it's just also incremental updates to including many bug fixes and improving the user space code base. Then in ipset, just a few updates. Basically, on the kernel side, the garbage collector was updated to run in a work queue instead of running from bottom half context for the hash set types. And then the wildcard support for the net iPhase set, that is basically a set that allows you to combine network addresses with interfaces. So, and then what else? We had the destination MAC address that is now that can be now used from the hash IP MAC sets. And in user space, there were 4 releases in ipset, from 7.2 to 7.5 to 7.6. Sorry. So what do we have in the connection tracking area is basically a new support for the bridge. There is a new module that is nfcontract bridge. It's registering 2 new hooks. It's registering the from the bridge per routing hooks. It's registering nfcontract in. This function is basically allocating the contract object and registering it into the contract table. And then you have the bridge post routing hook that is confirming this connection tracking entry in case that the packet went through all the hooks in the bridge layer, and there were no rule actually dropping this packet, then the entry is confirmed. There is also, since connection tracking requires to integrate requires to see packets, already the fragmented packets, you have to collect all the fragments and then pass them through the bridge layer, so contract sees all the fragments in one go. We also had to update the fragmentation, the fragment infrastructure, and to make it work for bridge. And what was done is basically an incremental update that tries not to alter geometry in a best effort approach. So it's whenever it's possible, packet geometry is respected. So it is left untouched. But if under some circumstances that is not possible, so then geometry is lost. The situations where geometry is lost are quite quite specific cases, basically when combining bridge with the Netfilter queue, for example, or we're combining the bridge layer with conntrack and connection tracking helpers also, because connection tracking helpers, they need to see a packet in a linear area, because many of the connection tracking helpers, they do pattern matching to basically they are doing layer 7 parsing, and they need to find the packet in a linear fashion. So in those cases, the geometry information is lost, and there is no and we would need to keep that context information around in some way to rebuild the fragments after leaving the bridge for those cases that I mentioned. But that is not, it's probably too much effort, and it was not work, that work was not done. So it's something to be done in the future. How do you enable the connection tracking bridge support? It's basically just whenever you use the city state selector in nftables from the bridge family, automatically it's registering these hooks, and the connection tracking bridge support is kicking in. So it's, this module does not, you don't have to explicitly load this module to get it working. It's just whenever you have one single user, I mean, in this case, the user is one rule that specifies the city state, then the connection tracking bridge support is enabled. This infrastructure is aiming to replace br_netfilter. br_netfilter, or also known as bridge netfilter, is an infrastructure that basically makes packets, make bridge frames, it makes them look like they are real IP packets, but they are actually not. So it's basically injecting the bridge frames into the IP hooks. So you can use iptables to filter bridge traffic. This was an idea coming probably 20, I think it was 20 years ago, and it seems to be like yes, this is something very interesting, but actually what we found in all this time is that we had lots of problem with this BR Netfilter infrastructure, because many of the iptables extensions are not actually not working, because the bridge frames don't exactly look like cannot always be, you cannot always make them look like real IP packets, and there is also a few corner cases when there is information that is lacking, and so this results in problems that cannot be easily fixed. So while the BR Netfilter infrastructure is allowing you to use iptables from the bridge, it is still having it is still having design problems that cannot be easily fixed. The kernel side city netlink infrastructure got also netlink dump filtering. This infrastructure allows you to filter the netlink dump operation from the kernel. This is quite useful operation when you have millions of entries in the connection tracking table. So you can just specify the filtering criteria from user space, and then the kernel is going to dump only the entries that you are interested on. So that's another update, and that is also the IPVS hardware offload bit. This new status bit for conntrack allows you to identify connection tracking entries that are in hardware. So this is something that with the new flowtable infrastructure that has been added, it's useful to identify what entries went into the hardware. So this new status bit just tells the users that these entries is not in the host, is not in software. And there is also an enhancement in the class resolution code, basically to deal with DNS flow packets. There is a raise that was triggering quite easily with DNS when performing parallel IPv4 and IPv6 lookups, and it was resulting in the packet losing raise to be dropped. and this is now solved. There is now a class resolution routine that is dealing with this case, so there is no packet drops anymore for this case. In the IPVS, in IPVS, the updates are also just a few of them. It's actually not much. It's on demand hook registration. So the Netfilter hooks or the IPVS Netfilter hooks are registered only when they are used. Before this, they were always registered. There is a small performance penalty in registering the hooks for every case, even if you don't have any single configuration in IPVS. So now this is only impacting performance only when you request IPVS to be used. There is also some small change to fall back to the connection tracking TCP, to the conntrack TCP tracker to handle connection reuse in IPVS, and also to queue delayed work to expire connections when they don't have destination, basically to clean tables much faster when the destination is not available anymore. The backend server is not available anymore. So it's just a few updates on that area. Regarding the flow tables, this infrastructure allows you to accelerate packet forwarding basically by registering a table, a flow table in the Netfilter ingress hook, and this flow table is making a 5-tuple exact matching. And if you find an entry in the flow table, then there is a hit, and you follow the fast path that is basically placing this packet in the neighbor XMID path. So it's bypassing the Heo classic forwarding path. So basically the idea is that if the packet does not find an entry, then that packet follows the classic forwarding path. But if the packet finds an entry in the flow table, then it follows this fast path. So basically the idea is that only a few packets, just the initial packets of a flow, they follow the classic forwarding path, and then basically the after the second packet is seen, then it's going to add an entry to the flow table. The first packet never adds an entry to the flow table. It's starting from the second packet, and the second packet of the flow creates an entry, and the third packet is going to find the entry in the flow table. So it's basically first packet follows classic forwarding path, second packet creates the entry in the flow table, and the third packet it's finding the entry in the flow table, so it's following the fast path. So, and all packets following after the third packet, they always follow this fast path. This fast path is a software fast path. So it was lacking IPVS support that is now available, and it was also lacking hardware offload support, which is now available with the Mellanox conntrack 5, and specifically integrating this infrastructure with the recently added TC-CD support. And there were also a bunch of fixes that went into this flow table infrastructure. Regarding nftables, so we got quite a bunch of commit updates since March 2019. It's basically a bit more than 400. 6 releases from 0.9.1 to 0.9.6, and then the upcoming 0.9.7 coming soon. Then we got contributions from 32 unique developers. And the main updates that went into nftables are basically new features available up to the Linux kernel 5.9 and many bug fixes. And now let's follow up with a quick summary on all these updates. So the first thing that it's worth mentioning is this packet, this payload matching for matching on transport header port information. So this new TH keyword, it's transport header. So TH stands for transport header. It's telling you, it's allowing you to match on the destination or source port regardless what transport protocol you have. So these source and destination ports are always on the same offset for many layer 4 transport protocols. So matching at this offset allows you to generalize rules a bit more, to consolidate your rule set. So the example there that you can see, the first line, it's basically telling you to it's matching on the IP protocol field in the header for TCP and UDP packets, and then all packets going to destination port 53 are accepted. So before this update, you needed to specify two rules, or to use the raw payload expression, which is not so easy to read when looking at the rule set if you use quite a bunch of them. So that's why we introduced it. We introduced this shortcut, this th keyword. And you can also combine the th keyword with concatenation. So basically building a tuple of three components. It's basically the destination address, the protocol, the transport protocol, and then the destination port, and then consult these, find a matching in the my set, existing set in your rule set. So in case that you find a match, you accept that traffic. There is now also support for matching on IPv4 options, specifically these four that you can see there. So the syntax is like you can see there. It's basically IP option, and then you specify the IP option that you are interested in, and then you can specify exist just to check if that option exists, and then you can specify some actions like drop, count, or counter, or anything you need. And you can also inspect the fields of these IPv4 options. You can specify the type, and then the type number. So what else? Coming next is the meta extension. So nftables now learned how to match on time. So you can specify time ranges, and these time ranges allows you to just to apply some specific policy to packets matching on that range. The range can be a full date, including year, month, day, and time, but it can be just time in terms of meta hours. So you can specify a range of hours, the starting and the closing time, and then you can also specify days. So this is basically providing a replacement for the iptables time match. And then on the segmar Segma support was added to nftables is CT segmar that you can use to check for the CT segmar value. You can assign a segmark to your connection tracking entry. This example is setting the segmar based on the meta mark on the segmark that is available in the packet. And you can also restore the connection tracking segmark and on the packet by using meta segmar set CT segmark. So it's basically allows you to store the segmar on the contract object and restore it on the packet, which is a very common operation. There is now also support to match on the bridge, VLAN, filtering metadata. That is also, this is a metadata that is all very specific of the bridge family. So you can just use the IBR PVAD to match on the VLAN ID and the VLAN proto of this bridge interface. Extensions for set and maps include range in concatenations. So you can now, if you specify, when defining your set or your map, the type is a tuple that is composed of several data types. Like in this case, if you specify also the flag interval, then you can define concatenations that include ranges, like the one you can see there. So the rule does not need to be updated. It's exactly like other concatenations. where you combine a bunch of selectors, and then you use the add keyword and the name of the set to perform a lookup on that set. So it's just that from user space, the only update in case you want to use this feature is that you have to specify when defining your set that you have intervals, and then you can do so with the flags interval option. What else? You can also combine this with type of. The type of keyword is new. It's you can use it to define sets in a more handy way. Every selector has a data type, and users has to keep in mind what is the data type for this key specifically. So you have to remember that for IP source address, the data type is IPv4 underscore ADDR, right? So keeping all these data types in mind is not handy. So this new type of allows you to just to specify the key name, the selector, and use it to define your set. So you use, instead of using as before, instead of using type IPv4 address, type IPv4 address, and I need service. Instead of that, you use type of, and you specify these selectors that you want to use for your set, for the set that you are defining. What else? The restoration of expiration time is something that was missing. It's now available in nftables user space on also kernel side. Basically, this allows you to restore the expiration time when you create a set, an element, or a set. You can specify that all entries have a timeout. So after that time, they expire and they are removed from the set. So what you could do in this case is that when if you have to reboot your system, for example, and you would like to keep that stateful information around, then what you can what you can use is that you can store your rule set, including this stateful information, in a file, and then when your system boots up again, you can just restore this stateful information, and so the entries resume from where they were, right? So this was not possible so far to restore this information. The workaround so far was to use the -s option for NFT, that is basically removing the stateful information from your listing, and well, this workaround is not needed anymore. You could just restore the expiration, that is basically telling you how much time left to expire this entry has, right? And that's it. So the next feature is the set element deletion from the packet path. So in your rules, you can specify the delete keyword and then add a specific set. And this you can use it to delete entries that are basically composed of the tuple, the specific tuple, or just one single selector that you specify. So basically allowing you to remove entries from the packet path in a specific set. You can use comments in sets now, which is something that users might like to have if you have a large bunch of set and you would like to keep context information around to allow someone else or yourself to remember what was the purpose of this set if the name is not explicit enough, right? So you can just specify comment and then a string between quotes. There is now a -t option. And this -t option allows you to exclude sets from the listing. It's a way to shorten your listing if you have many sets and those sets have lots of set elements. So and it can be also very useful in case you have dynamic sets that are updated from the packet path that gets many entries, and those entries are not relevant for your listing. So you just specify this -t option. It's basically the same -t option that you have in IP set. So now this is also available in nftables. So what else in nftables? There is support now for the set counters. So if you specify counters in your set definition, the elements are going to get a packet and byte counter. So whenever you list it, you can check the values of these counters. So and there is this if you save these counter values to if you list your rule set and you store this listing in a file and you would like to restore these values again for a situation where, for example, you have to reboot your system, then it is possible to restore these set counters from the file. So this stateful information can be stored in a file and you can restore it whenever you need to. So in terms of NAT updates, there is now, you can now combine you can now combine the concatenation feature in DNAT. So you can specify the NAT that is going to be performed based on whatever criteria you have. In this example there, you can see it's DNAT, IP address, and port. So it's going to do the DNAT. It's going to set a new destination address and port for this packet, and that's going to be based on the source address. So if the packet is coming from the IP address 1.1.1.1, then this packet is going to get a destination address 2.2.2.2, and the destination port is going to be 443, so 443. So it's just allowing you to make more fine-grained configurations to the destination, to do source NAT or DNAT, because this feature also works for source NAT. And there is also now support for, you can also combine this with name sets. So you only have to, on the right-hand side of the map definition, you have to specify the data type of the key value, right? In this case, of the value that you have in the map. So if you specify a concatenation, then this map stores this IP and destination port that is going to be used for the mangling. You can also combine this with, there is also now support for prefix, the prefix NAT, or also known in iptables as netmap, right? Netmap is probably a more popular concept if you are familiar with iptables, right? So the way to implement netmap in nftables is to use this new prefix keyword that you can combine with snat or dnat. So basically, you have to type snat IP prefix. So the prefix of the source address is going to be mangled, right? And the remaining bytes are going to be left untouched, right? So you can just perform prefix mangling of the source or the destination address. The way to specify this is to specify a address and a net mask. And you can also combine, there was a missing feature here also too that I just skipped. That is basically that you can use prefix and ranges in NAT. It's if you specify as NAT or DNAT to a range, then you are telling the NAT engine that the source NAT or destination NAT can basically select the whatever IP address in this prefix, or in a range. Please don't get confused with the prefix keyword and the range, and the usual range configuration. The usual range configurations with no prefix keyword, it's basically telling the NAT engine to pick one IP address from that range. And then if you specify prefix, then the prefix is is left untouched. So it's just no, sorry, it's the opposite. The prefix is mangled, and it's only the remaining bytes are actually left as is. They are not modified. So it's basically allowing you to make one-to-one mappings, right? So what else? You can also combine this with NAT intervals. So you could specify an interval and from an explicit map or set definition. In this case, it's an explicit map definition, and this map definition is allowing you to specify that the interval of possible source address that is going to be used for the NAT is belongs to the range of 192.168.2.2 from 2.2 to 2.4 basically. So all packets coming from this network, the 10.141.10/24 are going to be mangled to any of these IP addresses. So all packets leaving this network are going to use these actually two. It's two, three, four. Yes, these three IP addresses for the NAT. So this is in case that you would like to use the interval feature from explicit map definition. There is now also support for SIM proxy in nftables. So the classic, it supports for the classic approach that is basically mapping one-to-one to iptables. This mapping one-to-one to iptables have limitations. Basically, if you have multiple SIM proxy configurations, you will have to add one rule for every backend, depending if that backend has different MSS, window scale, and timestamp values. So depending on the diversity, the amount of different backends that you have, you might end up with lots of rules in iptables, one for each backend configuration, right? So to overcome this limitation, nftables provide SIM proxy support, basically allowing you to define SIM proxy objects that specify the SIM proxy configuration, one for each kind of backend you have, one for each TCP identity, basically, in the backend you have. This TCP information is useful to be included in the CNAC packet that is sent from the firewall on behalf of the backend, right? So in case that this connection is legitimate, right, we need to store a connection that is containing all the TCP extensions, performance extensions that allows this connection to evolve fine, right, while mitigating the SIM flood, right? So, well, you basically specify the configurations for the different SIM proxy backends you have, the different TCP identities you have. And based on this, combining this with maps, you can just set the SIM proxy policy based on whatever you would like. In this example there, it's based on the source IP address. So based on the source IP address, if it's coming from network 1.0/24, then the HTTPS SIM proxy policy is used, or otherwise, in case that it's 2.0, then other SIM proxy is used. So it's instead of in iptables, you need to add one single rule for each network. In this case, you use a map, and the map is going to find in O1 the corresponding SIM proxy policy. So there is also support for custom conntrack expectations. You can define a custom expectation. Expectations are basically allows you to tell the firewall that there would be a packet matching what you define in the expectation in a given time frame. So in the example there, it's defining the my expectation, And my expect is basically what we are expecting is a TCP packet on destination port 5432 and in 1 hour, and a maximal amount of 12 expectations can be created. So basically packets, if a new packet coming to port 8888 is seen, it's going to create an expectation. So this is useful, for example, for port knocking, or there are also different use cases for this, where you would like to, when you see traffic coming to one port and then you are expecting to see packets coming in another new port, and you would like those packets to get through by means of the city state related, right? The related state in the connection tracking is basically a state that is catching for packets that are related to some existing flow, right? This is used for a connection tracking helpers, for example, in case where in FTP, when you have control and data flows, separated flow control and data flows, and the control flow it's announcing where the data flow is coming, right? So these packets, the connection tracking helper is creating an expectation for you, and then it's basically tracking that packets going to the data in the data flow are matching this expectation, and so those packets are let they can go through the firewall with no problem. So it's just this is a way to define lazy connection tracking helpers, basically. So without the need of adding a new specific connection tracking helper, right? You don't have to. You can just add this rule, define the expectation policy, and if you find a matching, that creates the expectation, and that packet is going to go through the related state. So there is now support to reject packet for VLAN from the bridge family. So in case that the packet is covered by it's encapsulated in a VLAN tag, in a VLAN frame, you can just reject those packets, and the TCP reset packet that is going to be sent back to routing is going to also include the same VLAN header. And there is also support for rejecting traffic from pre-routing, which allows you to reject traffic earlier than iptables. iptables allows you to reject traffic from input or forward. Pre-routing support was not available, so now this is available. It's an extra feature in nftables that is not. The updates regarding the Netdev family are basically the multi-device chain support, hardware offload, and these two basically. The multi-device chain in Netdev allows you to specify multiple devices. So this chain, in this example chain that you can see there, it's basically creating a chain Y, and this chain Y is registered in the ingress hook, and you have ETH0 and ETH1 that all packets kicking into these two interfaces are going to walk through this chain. So this allows you to consolidate your rule set. So you don't have to, before this feature, you had to define one non-based chain with a common rule set for ETH0 and 1, and then add a rule to jump from the ETH0 chain to this non-based chain, and the same thing from ETH1. So this is allowing you to consolidate your rule set a bit more by specifying this array of devices for this ingress hook. There is now support for the hardware offload, and as I mentioned before, this hardware offload support it needs to be turned on in iptool. There is a toggle to enable it. In the future, we are planning to basically turn on this iptool toggle without requiring the user to make it explicitly, because in nftables you have this flag offload that is placed bold in the presentation that you can see there. This flag offload is telling you that this rule set, this rule set in the ingress chain is not actually going to run in software in first place. It will run in hardware. And so the filtering is happening in hardware. So there, all packets going to IP address 3020 are going to be dropped. In case that so it's basically providing you an alternative to the existing TC hardware offload support for filtering traffic from nftables. This packet is dropped in the NIC, so it's a real hardware offload. Support for the Netdev family is relatively limited at this point. Is basically you can match all packet header fields, and in the meta information, the input interface, and then actions available are accept or drop. And then you can also duplicate the packet or mirror the packet to a given port through forward, or duplicate the packet through the dup action. One important thing to mention about the hardware offload is that chain priority needs to be set between 1 and 2 power 16. This is something that it has been inherited from the TC infrastructure, that is basically only having this amount of priorities, and once drivers are updated to support, or if hardware support more priorities, it should be possible to remove this limitation. So in case you give a test to the hardware offload infrastructure, just make sure that your chain definition, when you set on the flag offload, is between 1 and 2 power 16. I've been testing this with the Mellanox Connect X5 card, and it's working quite fine. It's what else? nftables, flowtables now have counter support, so you have to explicitly tell that you would like to account for packets and byte following the fast path. You only have to, when defining the flow table, you have to specify that this counter keyword, and you can list these counters through conntrack -L. There is also support for updating flow table devices. This support for updating flow table devices allows you to add new devices to an existing flow table. This is very useful for dynamic interfaces. If you have a PPP interface or some kind of interface that is dynamically created, then you can add these devices to your flow table through just NFT add flow table, and specify the new devices that you would like to see to be part of the flow table definition. So now there is support for updating flow tables, and there is the scripting capabilities of nftables has been enhanced. Variables can be now used in chain definitions. And if you would like to have a variable to define the default policy for your chain, you can just use it. The same thing for priorities. Some people like to keep all these variables in some common .nft file, and then have some common rule set for different boxes, and just update the variables according to your needs, or what yes, basically that. So the empty sets in variables, it's something that allows you to refer to variables that contains no entries. Well, actually in this example there, you have to make sure that at least one of the variables contain one single entry. It's not possible to use a full empty set definition in the rule. So if you specify TCP, the port, and curly brace, and then closing curly brace, that will not work. So, but in this case, the nftables is merging these two variable definitions that contain sets, and since the set is not empty, there is no problem. So here, just in case you would like to have a way to extend the base allowed incoming TCP ports, you can just specify this empty set definition. So it's something that just usability, it's usability enhancement, more usability enhancement regarding the use of variables in NFT. You can specify now variables in log prefix. So in case that you have some login action according to some criteria to match packets, so you can use these variables. There is also variables that you can use in device, um, in device names, in device definitions, in case that you have an ingress chain. And one new feature coming in since 5.9 is the definition of implicit chain bindings. The implicit chain bindings allows you to group multiple rules into one single implicit chain. This implicit chain, well, as you can see there, you can specify jump or go to as usual, and then basically you are restricting the jump to whatever selector that comes before. In this case, there in the example, you can see that this destination TCP port 22. So all packets going to this destination port are going to jump to this implicit chain, and there you can keep the rules that are going to be evaluated. It's another and usability enhancement. Of course, if you prefer to define explicit chains, you can just define an explicit change and jump to this change. The implicit chains cannot be updated. So it's something that once defined, you have to remove the rule or replace the rule to update it. There is now descriptions for data types. So you could use NFT describe. Before, you could use it for selectors. So you can do NFT describe IP as ADDR to describe the IP source address keyword, the IP source address selector. Now you can also use it for data types. So if you specify IP for underscore ADDR, then it's going to describe the kind of data type this is, and telling you how many bits are expected, and if there is a name for it, and if there is any kind of base type, in this case integer. There is now also support for line noise as a replacement for lib red line. In case you would like to compile nftables, some people like to use this alternative in embedded environments where there are restrictions or of there are limitations in terms of storage, and you would like to have a more lightweight library for auto completion, and for the basically for the interactive mode of NFT that you can invoke when calling NFT with -i. It's like NFT -i gets you into the native nftables shell, and that is using the red line library and also the line noise. So there is also a few updates on NFTLB. So two releases, 0.5 and 0.6. The 0.6, this NFTLB is the nftables load balancer. It's a software that you can configure for load balancing. The main updates that you have in these releases are basically the conntrack offload support through flowtables, and now the flowtable can be enabled from NFTLB. There is ingress support for FAMs. There is also dual stack, DSR, and stateless NAT. The improved backend health checks, just basically to make sure that the backends are still available, and there is a REST API that you can use to send incremental updates to your NFTLB configurations that has been also extended. And then just last but not least, is just a discussion about some topics that have come up in the mailing list regarding the egress hook and the IFB ingress hook. So basically, regarding the egress hook, there is There is a number of use cases where this new hook can be very useful for us. We've been discussing this internally in the core team, and it's something that we would really like to have. The concepts that have been raised so far on the mailing list are focused on performance, keeping the hook behind the static key um, is actually hiding any performance impact on this. So it's basically it's actually very hard to measure if there is anything any real impact on this. It's um, so this all this benchmarking was done already when introducing the ingress hook, and the conclusion was that performance was not an issue, and if you don't use it, you don't get any impact. And then the other concern was about interactions with other software, but this is something that can be easily debugged by the user. And if the user, as we discussed so far, is like if the user don't like the Netfilter infrastructure, I would like to prefer would like to or would prefer to use anything else. So it's just a matter of compiling out the Netfilter support, or just making sure that the user installs no software that uses Netfilter. So this is not a problem at all. So there are different several possible solutions, and in any case, the the um, the outcome is that if the user does not use this new hook, there is no the performance impact is negligible, is actually very hard to measure. There is another IFB ingress hook for some use case that has attracted my attention, basically just um, to allow you to combine shaping both for ingress and egress. And it's something that also I might also post patches regarding to include this IFB ingress hook support. So that's basically all what I have. Thank you so much for attending this presentation, and that's basically all I have.